First of all, thanks again for your attendance. Thanks for being here. To be honest, it's not a perfect job to be the last talk of the day. A lot have been told already in the previous presentation. So I think my presentation, so the global topic was about at Scaleway, our challenges, and most of all, the solution that we are trying to find, even if it's still work in progress. But I think we have the same challenges that was already exposed. Anyway, I hope, as a conclusion, I think that it's justified, gives some more credit to the existence of this conference, because at the end, we are all repeating a lot of stuff, and we still have a lot of common challenges. So first of all, a couple of words about Scaleway, just to give the background, the context, our operation, and just also to introduce why in the 3 next chapters, I will talk about the challenges and also the solution that we found or we are working on. I've decided to expose this via 3 different perspectives: the form factor, the density, and the maintainability. It's a large topic, so I will not have time to go into deep details. Maybe it's a good excuse for a next edition to go into deeper details. We will see. So Scaleway at a glance, a couple of words. So Scaleway, we are a European service provider. We are running multi-AZ redundancy. We do operate in several countries in Europe. We are operating in a sustainable data center as much as we can in France, in Netherlands, in Poland. One point to highlight is about this program. We call it Second Life or Transformers, depending on internally, externally. The idea was to put the server, to reuse the server for a long period of time, up to 10 years. We also celebrated 14 years of one of our Dell R210 a couple of weeks ago. So yeah, we are trying to have our servers in production for a long time. The reason for talking about this is one of the reasons why we have some challenges and we need to find some solution. Oops. Just wanted to also say that we joined the OCP Foundation late last year. First of all, our goal is to continue to experiment the OpenBMC stack. We are trying to make it our stack, our own stack, something we are working on. And also on the hardware side, on the DCMH head, that's something we are working on with HPE, with Dell. That's something really we would like to go for. And also because we have partnered with HPE to provide this OCP Experience Center that we have available in France. The goal is to offer a platform to test open firmware. So right now it's running on HPE machine, but the goal is really to be able to put some more hardware on it in the next few months. As of today, we have only 1 rack, and we will add another rack in the next few months. Just very few words about myself, just to introduce. So I come from the vendor side of the force, so I spent 20 years of my life at Sun Microsystems. Sometime at Oracle, you notice lowercase for Oracle. Just kidding, but we did some great stuff, but it was a good time anyway. But so I joined 6 years ago. I'm currently the lead of the hardware team at Scaleway. So it's I'm leading something like 20 people in the team. Our responsibilities, it goes from the architecture of the solution, trying to find the right hardware solution to provide to our Scaleway product team, the design of the rack, so the rack that we will put in production later. I have a team of developers responsible for creating in-house tools, internal tools, for the configuration, the quality, the manufacturing as well. And also the team responsible for the maintenance of the whole install base, which is a big job. I forgot to mention that we are part of the operation department, It's, in my opinion, an engineering team that's part of the operation, because we like to have this global view of the whole operation, from the supply, the logistic, the deployment, the data center deployment, the project management, and stuff like that. Very few words about our product. I'm not here to present the Scaleway product, but just to put the reason why I'm talking about this challenging and solution in the next slides. Basically, very related to hardware, the three important products we have is bare metal. So we are providing dedicated servers. That's the heart of Dedibox many years ago. We were founded in 1999. That was this dedicated servers business. So we have this bare metal world. We have the public cloud, which is different. And so it requires different hardware. It requires different solution. Of course, I'm talking only about hardware today. Of course, it means a lot of products, just like managed services or databases and stuff like that. They are our customer. We are a support entity. We are supporting the other internal organization in the company. And finally, the AI. I'm talking especially about what we would call the GPU as a service. That's something that we have to maintain, to put in production, to support, to find the right solution for it. The title of this presentation is How We Operate a Large and Diverse Install Base. Just to provide a little bit of background about large. Why large? Large in quantity, because we are operating thousands of servers. I will not provide the exact number, but I can tell you it's a 6-digit number. Geographically, because we have several regions, several AZ, in different data centers with different infrastructure. This is also a constraint we have to face. A lot of product, because we are covering a lot of variety. I was talking about AI, I was talking about cloud, I was talking about bare metal. I can add the compute side, the storage. We also have to provide the right hardware assets for internal infrastructure, commodity hardware. So it's also a large install base in the quality, I would say, of the machine. Sustainability, because we are trying to be as sustainable as possible, running on free cooling or adiabatic cooling as much as we can. And also one of the specificity, and what I put in the large definition here, is about continuous deployment. We are not deploying twice a year. We are deploying every week. Every single week we put rack in production. And we have to deliver this. From the procurement up to the deployment, discovery, we have to deploy every week, if not every day. Diverse, because we are running server for up to 10 years or 14 years sometimes, so we have to maintain and to keep in production a lot of machine. At some point, we were up to 37 types of machine or flavors. Someone talked about flavors earlier today. That's exactly the same word for us. We had 37 flavors of chassis in production. It's a lot of firmware, it's a lot of spare parts, it's a lot of chassis and stuff to maintain. It's not ideal, that's not what I'm saying. I'm just saying that at some point we had 37 types of chassis. And so we have a mix of all of these flavors, generation and version of firmware. And also, of course, I had some discussion with some of you guys earlier today. It's a lot of mix of technology. We are still running SAS disk. We are still running HW-read, hardware-read card. That's a challenge, finding an hardware card today with a battery. It's also a challenge. Anyway, that was for the oops, wrong button. So that was for the context. Again, the idea is to say we are a cloud service provider. This is the context. This is the background. This is what we have to operate, generally speaking. And the idea is the next slide is to go through these three perspectives and to give you some more information. Again, there will be some repeat. I see it as a good sign that we all have very common issues and constraints, and most of the time solution. So from a form factor perspective, as I said, we have many products serving a lot of purpose. I'm talking about storage, talking about AI, dedicated, compute, different generation. For the bare metal stuff, we need to be able to provide a cheap machine, low level, cheap for the user, low end, product, or high end product as well for some others. It's a lot of machine. It's a lot of form factor. From our perspective, we are not the end user. We are providing hardware for our customers. We have no full control of the software stack that will be running on the machine. We don't know if you guys are having one of our machines. We don't know what you will be running. You will be running full load or just 20%. We don't know. That's something we have to consider. The one size fits all doesn't work for us. 1U, 2U, 3U, 4U, we have everything. As of today, we have to deal with everything. There is no perfect solution for everything. Rear I/O, talking about the form factor, why not? But when you operate in hot aisle, you have everything. You have to go from the back to the front. That's an issue. It's a problem with density as well. This is in the form factor chapter, but we can talk about this in density chapter as well. It's not good for maintenance. I could put it in the third slide, in the third chapter as well. Obvious impact, usual discussion, 2U, 5 fan size, the impact on the power consumption of the fan size, etc., etc. We all know this part. The 1U form factor is no longer a solution, to be honest, for many reasons. At least for us, that's our perspective, right? I'm not trying to talk for everyone, but the configuration. We have a basic usage of the servers. We don't need 12 PCIe slots. We don't need 64 DIMM slots. So most of the time, not every time, right? But most of the time, the configuration are overkill. I don't care. I don't want to pay for this 12 slot. I just will be using one, the OCP one, the one routing the BMC, for instance. I don't care about the 11 other slots. So that's something we have to find a solution. It's not so easy to find. I'm not saying again there is no solution. I'm just saying it's hard to find a solution. Personalization and customization might look similar. Just my definition. Personalization in my mouth, in our terminology, is, for instance, you have a server, a chassis with a specific configuration, and you want to put one disk, 2 disks, for instance. That's a personalization. It's personal to the end customer. Customization is more like you want a machine and it has 8 gig of memory, you want 16 gig, we will do it on demand. That's two perspectives. Similar, but not the same for us. And this is something that has an impact on the form factor as well, because sometimes it's not the same form factor. We need 2 different flavors. Or we have to buy 2 different flavors because the trade-off is not available on the market. And bare metal and server and cloud server, they don't always have the same configuration. It's not always evident that one chassis will work in both worlds. And so we have to find 2 solutions. So I was trying to list, maybe it looks like a list, but to expose most of the challenges in this form factor chapter. One of the solutions we are looking at is to be able to use chassis with front I/O. Again, being able to have the I/O from the front, then you can operate from the front. That is good for the maintenance, for the DC tech, for the serviceability. You can improve the density sometimes. You can improve the cabling. You have some space optimization. Even if you are running adiabatic, you have to be very careful about the containment of the rack. And that's something that helps. Less cable, less space, less holes, more efficient. The configuration flexibility. My Christmas wish list would be to be able to have like a catalog of myself. That's something that we are doing. It's not easy, but that's something we are doing. We are trying to get this manufacturing level 6 plus CPU machine, and then we put our on disk on it. We put our DIMM on it, but the problem is how to make sure to have this level 6 plus CPU machine available from the vendors. It's not always easy. For us, what's interesting, if we can have this machine without any disk, but with the bracket, which is sometimes a challenge, to put our own disk, is that we have a better control on the spare parts. We are doing our own maintenance. That's our specificity as well. As of today, we are still running our own maintenance. I have a team dedicated for the maintenance, so we have to find the spare parts. And even if you have a great contract, I need to be able to replace the DIMM like that. So I have a team responsible for sending the tapes, the text, and so on. So if I have to wait even 1 day or 2 days to get the parts, it's too long for me. In my case, again, that's my perspective. With regard to form factor, the solution we are working on is DCMHS. That's really something that we are looking at seriously. We are investigating several solutions. There are some good improvements from different constructors, from different vendors. Very interesting. The idea is to improve the modularity. To limit, for us, it's a way to limit the number of chassis flavors. That's something that will help in the field. Instead of having these 37 types of chassis, it might provide one of the solutions. Also, it provides consistent form factor across the whole install base. Not one. There will be no one solution. It's multiple solutions, but still it reduces the number of solutions. The pending question in this area are still about the replacement. The point is about, for instance, the DCSCM. If I'm using a machine with a DCSCM running OpenBMC and I have a problem with this DCSCM, if I have to roll back to Hydra, Kylo, whatever firmware, how can I do that? It's not possible, right? And so I need to find a solution for that. So that's a pending question. I know there is some work in progress, right? But still, it's something that we have no final solution on this. And maybe the interoperability, I know there is also some work in progress in the OCP project to be able to move my DCSCM from one Dell machine to the HP one, to the Supermicro one. That might be perfect. Again, maybe a Christmas wish list, but I'm still a child. Customization, defeature, that's also something that might help. Defeature for me is to remove some part or feature from the system to make it simpler. That's the reference is about the 12 PCIe slots. That's something that might help as well. I know it's not easy. Again, it's not an easy stuff. Same for customization, but of course it's cheaper, but it's not always the reason. It's also because if you put less components, you have less defect. Someone said earlier today that the best RMA is then you don't have any RMA to do. So that's perfect. No SPOF, no useless redundancy, and easier maintenance as often. Density. That's the topic of the roundtable, so I don't want to provide some more about my opinion about the next years, but we have a specific perspective about density because we are not the end user. We are not looking at the density at the chassis level most of the time. We are more looking at the density at the rack level or at the room level. Adding more CPUs to more cores to a CPU, it's not always a solution for us for many reasons. Also, one very important point for us about the density is that since we are not the end user, to provide the best infra from a power perspective, we have to predict and anticipate. We are a service provider. We do provide servers to someone that will be using the server. What will be their load average? I don't know. What will be the workload? I don't know. Is the rack will be fully in use? I don't know. It might be from 0 to 1% used. That's a huge difference. So I have to predict. I cannot underestimate the number of kilowatt of the rack. I need to find the right numbers. Of course, we have some abacus. We did a lot of work in the last 6 years to improve this, but still we have to anticipate. And of course, the redundancy aspect, because if I have two sources of power, I cannot assume that the two PDUs will be in use every day, because if I lose one way, that's an issue. Dual socket, we are talking about density, so adding more CPU in a chassis, not sure it's a good idea for us, because once again, we have to find the trade-off between how many VM we will put in the HV. If there is too many VM, if you lose something, that's as many VM that are done, and many customers not happy. So that's why for now we are still looking at single socket servers. The dual socket server, we have that, but for very specific case. It's not something that we do avoid, but it's very dedicated to a very specific use case. The impact, of course, the density has an impact on the cooling. The presentation about immersion cooling was great. It was very interesting to see the perspective, the feedback from a user, and not the presentation from the vendor. So it was great. For us, immersion cooling, it's too impacting as of today. That's something for many years, in my opinion. However, we have to consider the DLC. That's something we will have to consider. The challenge for us, because we are talking about challenge, will be to mix air cooling and DLC. I think we will have to. Again, depending on the product, we won't be able to provide to use liquid cooling for the low-end servers, and it would be stupid to continue to use air cooling for a big GPU. Makes sense. The density, of course, one of our goals is to make to have the best cost effectiveness on the rack. So it means that we also have to consider the availability of the ports on the switch, the cost of the port switch and that's something that may impact. When we put in production one rack with 10 chassis, it's only 10 ports in use. That's a waste of port, waste of money. And also because we are operating in many DCs, in many data centers, we have to consider sometimes different standards. Some other country does not have the same structure. Sometimes it's we have to go through 3 phases just because that's the way it is. Just to get 8 kilowatt, that's an issue, right? So, and my goal is to provide standard. That was my first job at Scaleway, was to standardize the rack level design. And it's not always easy in that perspective. That's why it's in the list of the challenge. So again, some solution for this. I will start with the second point, the second bullet, about DLC and air. Like I said earlier, depending on the product, depending on the cost of the product, the cost effectiveness and the DC readiness, which is also important because I won't be able to go everywhere with this DLC solution. I will not go to a data center. I will put one rack, and the second one is just for the plumber, for the water. It's not possible. I will have to pay for 2 locations. That's not possible. So we have to be very careful about that. However, we have to go this way. We have to go this way at some point. And adaptability, maybe it's not the right wording, but the idea was we have to be able, again, to go everywhere as quick as possible, I would say, and to predict this, to be ready, and to adapt the location or our design to the location. Trade-off between workload, as I said, usage rate, I mentioned this before. It mainly impacts the rack level design again. If I have a target at 6 kilowatt or 7 kilowatt, I have to make sure if I using not enough server in the rack, it's a lot of money for the company, right? Because we could do more dollars, but we are not. So that's the point, and that's the key point, to be able to find the trade-off really between all of these points. And to maintain the redundancy, of course. More and more cores in the CPU, again, it's not the solution for us. Again, depending on the product, it might be a solution for customers requesting a lot of cores, requesting a lot of power, but that's not all of our customers. And we have to try to find product, the best product for our customers. The product portfolio has to be as large as possible. That's the idea. With regard to density, one of the solutions we are working on at the moment is the Open Rack. Say it correctly. Open Rack v3, including front I/O. That's really something we are looking at the moment. It's quite new, I would say, still. We have good experience so far. We are still working on it from a density, from an assembly, from a rail perspective, it's easier. From a maintenance, you don't have to ask the guy to go in the hotel, you can stay front, blah, blah, blah. No more cage nuts and stuff like that. Power efficiency with this continuous current stuff, and the power shelf, less PSUs, and it's also impact a lot the power efficiency. That's some points we are looking at. Again, it will cover part of our product portfolio, not all. This is not applicable for all of the use cases as usual, but it will cover a lot, in my opinion, in our opinion. The last, good on the timing? Maintainability perspective. Again, I mean, it's probably the part where we already talked about this earlier. Firmware, it can be a pain. It's not always easy to maintain, to control, first of all, to put in production, because the interfaces are usually outdated. I'm talking about IPMI. The transition to Ragefish is not so easy. Someone, again, mentioned this earlier. It's not really a standard. It's still difficult. It may vary from a vendor to another one. It's a step forward. It's not the best step moving forward. And we are still seeing some proprietary stacks in the field, and that's really an issue, again, when you put in perspective the fact that we are running many chassis, many versions, new or old, right? I'm not only talking about old machine, I'm also talking about new one. It's not always easy. You know, when you have to deal with the IPMI and you have to find the raw command to do that, or blah, 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 it's really a nightmare. We are running this continuous deployment, so we have to manage these different flavors. So that's something we have to do. I don't think there is any perfect solution, but there is some way to improve this anyway. We talked about the generation and version earlier. The support model. As I said, the way we are working as of today, this might change in the next years or months, but as of today, I have a team dedicated to the maintenance and providing our own model in the company. But still, we need access to the support of the vendors. And the way we work is that we would prefer to have access to engineering in the early days. But then usually we don't really need so much access to the vendors. And also one other thing during the run, so when the servers are in production, is to be able to access the spare parts, which is not always easy. If you have to spend 2 weeks to talk to someone that will accept that it's an hardware issue, and then 2 more weeks to get the disks, it's a problem. So that's a trade-off, again, we have to find. By having the spare parts available locally, but it costs a lot, as we all know, it's really a cost. But anyway, so that's really a challenge this support model is not appropriate for us. Access to parts, again, when you move from a generation to another one, the format change, you have to change. You cannot use the same PSU from one machine to another one, Gen 10 to Gen 11, 11 to 12, whatever the number, whatever the vendors, it's still very difficult. And sometimes the easy approach would be to go for complete system. Let me rephrase. Earlier, I talked about the manufacturing level 6 plus CPU, which means that you get the board, the CPU, you put your own DIMMs, so you control the disk. The DIMMs, you put your own disk, you control the disk's reference. So yes, of course, it's a lot of logistics, and you have to predict everything. So the easier idea would be to go for the complete system. So you buy the machine with the CPU, the DIMMs, and the disk. But I don't know what kind of reference I have in the machine. I come from a vendor, I told you earlier. It could be 4 or 5 disk reference. I have no idea. So how can I organize my spare part logistic if I don't know the disk in the machine? Same for the DIMMs. But this comment is especially for the disk, but it's still valid for the DIMM as well. In many cases, we need to be able to put the exact same DIMMs in the machine. All of this install base with many machines and stuff like that, we had to invest in tools, and this is great because we can do what we want. I would say we can adapt our own tools to make what we would like to do. And since we are having a lot of hardware flavors, we have created tools that are agnostic of the hardware flavor. This is great. But this is still a challenge. I'm not saying we have no solution, but it's a challenge. Every day there is an update of the code because we are dealing with the new DIMREF or new servers, new command in raw command to add for IPMI tool, whatever stuff. Complete system implies no control of the disk. I think it's a repeat of the previous one. Packaging, we are trying to have a sustainable approach as much as we can. When you order 10 servers, you get 10 pallets. 10 pallets, 10 cardboard, 20 guides, 100 of CD or DVDs. Power cords are not suitable for the DC. Solution exists. It's not good, right? It's too many pallets, too much waste, too much cost, too much energy, not good for the planet, blah, blah, blah. A lot of reasons for that. Again, this is my perspective because we are also having a volume, of course. If you order one server, you don't have the same challenge, right, and the same constraint. But still, it's mine. Firmware. Like I said, several months ago, almost 2 years ago, we started some work on the OpenBMC side. We are not moving as fast as I would like, but it's a difficult journey. Or let me rephrase: it's not an easy journey. We still have pending question, but still, we think it's a good approach because it provides Redfish implementation. It provides standard interface. We still have to work on it, but this is one of the solutions. My team is providing hardware for the next product team in the company. As of today, for this server, you have to use this command. For this server, you have to run this command. My goal is to be able to do this engineering in my team and to expose the same interface to every single team in the company. That's my ultimate goal. Again, Christmas wish list, but why not? Yes, it requires in-house skills, but that's something I would like to go to. And also when you want to go for internal solution, I mean trying to do some own design or custom design just for us, it will help because we have the skills to develop our own firmware. I'm not trying to create a firmware from scratch. Don't get me wrong, that's not my goal. I don't have the headcount for that. But still, if we can get the minimum level of information from the vendor, and then we can put our own feature in it, we don't have a lot of feature. We don't need a lot of stuff. But we would like to be able to modify, adapt, customize this stuff. The pending question, though, the source code delivery, how is it available? How can we contribute? How the images are made available? How will work the RMA, the rollback? Should we have to roll back to whatever version of firmware, proprietary or not? The adoption and compliance, still a question in my opinion. We don't see so many companies using or going for OpenBMC. Yes, there is some traction, but we still have to work on it all together. The transfer of ownership, I think we had a discussion earlier today. It's still a point, right? The signature, who will sign the image? How will work the transfer of ownership? Maybe the SCM interoperability is also one of the pending questions I should have added to the slide. The Experience Center, go and try it. It's free. Just go have a look. You can try, you can upload your firmware. To be honest, I haven't tried it myself, but Elias will be able to give you more information if needed. That's something we did in partnership with HPE and Jean-Marie, who's not here today, but unfortunately. But mCRISPR, that's one of the solutions that we are looking at for reducing the number of form factor for the PSU. I think it stands for Common Redundant Power Supply. The idea is that many platforms will be using the same form factor for the PSUs. And so all you need to take care of is, I need a 1 kilowatt PSU, that's it. And you can buy it from Delta, from anyone, from HP, from Dell, from everybody, and you can use it in the server compatible or compliant. That's a good stuff. The bulk packaging, that's a good stuff as well, available from some of you. Sometimes we do buy 10 servers. It comes in one pallet, no cords, no guides, no DVD, just the server in one pallet. That's great. The waste is minimum, and that's a good solution. Of course, depending on the size of the chassis, blah, 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 but still, it's still better than to have to have one instead of 5. Adapt the service model, I mentioned this earlier. Better access to the part during runtime, faster access. In the early days, what we need is to be able to access engineering, to raise some bugs, to get the solution, the fix, and to reduce the TTM, just to make it short. L6, that's also one of the solutions. Again, that's not the solution for everything, but it's a good way to move forward for us. Customization, defeature, again, less component, less feature. Being able to talk to the vendors and say, okay, I don't care about this 12 PCI slot. If there's something that we can do, maybe the PCI slot is not the right example, the perfect example, but there is some stuff that we don't care. If there is 4 on-board interface, I don't care, the 4 on-board interfaces. There must be a solution, a trade-off between all of this. And I don't want to pay for this. That's it for me. In conclusion, what I wanted to say is that it might look like a list of complaints or constraints, but still, the idea was also to provide some solution. We have some solution we are working on. I hope we will be able to talk about this later today or next week or whenever we want, maybe in the next edition of this conference. So it must not be seen as something negative. That's something we all have the same challenges, so we can find some common solutions.
Okay. So thank you for the great presentation. You mentioned a couple of points which are really interesting, the move to DLC and the move to OCP. So I was just wondering if, Scaleway was considering merging these two technologies.
As I said, DLC is not for the short term, in my opinion. It's more like a mid-term solution and dedicated to some product. We have a large portfolio, I guess you know it, from the START solution, which is dedicated, let's say, low-end product, up to the GPU solution. We won't be able to find one solution. So we will investigate the DLC part in the next few months. Maybe, YG, you can say more about this, but that's something we will be working in the next months. The second point, sorry, was DLC.
There was just one single point. I just wanted to understand if
the
DLC
OCP
and
part.
OCP,
Yeah, OCP
could
part.
be an option together.
Same for OCP. I think our business midterm will the consequence will be we have to deal with many technologies. We continue to have regular machine from the market. We'll continue to investigate some OCP solution using DCMHS or not, and so on. So, in my opinion, I'm seeing a mix of all of this technology for the next months or years, definitely. But still, I don't want to be late, I would say. I've got people working on the open rack solution. We have to be ready when it will be more common and more available in the market. We don't have so many DCMHS solutions as of today, right? But we would like to investigate and to be ready to say, yeah, it's good, it's not good. Provide feedback if possible, and that's the goal.
Thank you.
Merci. ORV3 type racks are always associated with high density. To date, if I'm not mistaken, your average is between 6 to 10 kilowatts per rack.
Correct.
When I see ORV3 type design, it's more in the likes of 20, 40, up to 120, maybe 250 kilowatts per rack. Are you guys ready?
Again, we will go for only high density. I mean, a lot of servers in a rack. And I would say we won't go for 100 watts, 100 kilowatts, right? But still, the idea is to raise the power capacity of each rack to raise density as much as possible. And again, I'm not seeing tomorrow putting many GPUs in an open rack. That's not the goal as of today. In the next years, maybe, but not today.
Let's re-talk about it starting at January.
Okay. Which year?
2024 on our side.
Réveil.
You are speaking a lot about bare metal and your bare metal constraint. I would like to understand what do you see in terms of evolution between bare metal and virtual infrastructure. And as you might imagine, so I'm asking the question because in fact, if you are looking at the cloud service provider market at worldwide level, the trend is more indeed toward the density, density with a high power rack and a lot of cores, a lot of memory bandwidth, and so on and so on. The idea is to really to pack a maximum of the customer and workload per rack, where you are describing something which is more, I would say, denser, but you don't want more power, you don't want these kind of things. So I just would like to understand what's the business evolution and trends from your point of view.
I would say that, again, it depends where we are going to and the volume we are putting. What I'm trying to say, and I will try to use very ultimate example, just like if we want to go and we rent a full data center, we will not use the same solution as if we go to a room with two racks just to, as an edge, for instance, to test in this location. But of course, the idea, ideally, will be to raise the number of servers in the rack. Mm-hmm. If we have to raise the power consumption, that's fine. If it fits the physical constraint, I mean the number of use, if it fits the kilowatts available in the room and the infrastructure, the facilities, the DC facilities, then we are fine. And my goal is really to be able to be flexible. As of today, I think we have to be flexible to cope with the market and every possibility. I don't want to say to my boss, I don't want to go there just because I don't have the right design for that. I would like to be able to adapt this. I don't know if it answers exactly your question, but I would like to, and just to be sure, the talk was not only about bare metal because I have to deal with the virtualization part as well. The cloud machine, they are running on they are running on the machine that my teams put in the data center. So of course, as much as we can, to put a lot of servers. But again, I will be more limited of the. Back to my previous slides. I would like to raise the number of servers in the rack, but I cannot raise the number of CPU in the rack because it would be too dangerous. That's why I have to consider the physical limit of the rack as well. Otherwise, I would put octo CPU everywhere. That's not a solution for us. It does not work. Of course, it's not realistic, but you see the idea. So I need to find a trade-off. But yes, you are right in the fact that as many servers in the rack, as much money we can make, right? So.
That makes me think about something. If you could design your own data center with your own characteristics, are there some wishes that you expressed here which would change, or would it be the same?
That's a good question. No, I mean, I would like, to. I think we have to be able to raise the power capacity of every single rack, because for our business it's very important. And I wish we could have always the same design everywhere to make it more, automated and industrialized. So I will try to do something like for most of our business. I would say that let's say 20 kilowatt rack would be something perfect. If it fits again the physical constraint of the rack, if I can put enough chassis in the rack to make it work, that would be perfect. But again, it's not always possible. Thank you.